Digital fabrication technology, also referred to as 3D printing or additive manufacturing, creates physical object from a geometrical representation by successive addition of materials. 3D printing is a process for making a physical object from a three-dimensional digital model, typically by laying down many successive thin layers of a material. It brings a digital object into its physical form by adding layer by layer of materials. In this session, you will learn all about 3D printing. So without further ado, let's start the session.
Before we begin, don't forget to subscribe and press the bell icon to get latest updates from Intellipaat. And in this session, we're going to talk about what is 3D printing. So let's take a look at the agenda for this session. First of all, we are going to introduce 3D printing and the 3D printing process. Moving further, we're going to talk about the printing materials, the design guidelines, and the benefits of 3D printing. After this, we're going to talk about the history and the types of 3D printing. And to sum up this session, we're going to talk about the printing software, applications, and future scope of 3D printing. I hope the agenda is clear to you. So without any further ado, let's begin. 3D printing is an additive technology used to manufacture parts. It is additive in that it doesn't require a block of material or a mold to manufacture physical objects. It simply stacks and fuses layers of material. It's typically fast with low fixed setup cost and can create more complex geometries than traditional technologies, with an ever expanding list of materials. It is used extensively in the engineering industry, particularly for prototyping and creating lightweight geometries. Now, what is 3D printing? 3D printing technology, also known as additive manufacturing or AM, refers to processes used to generate a 3D object in which layers of material are successively formed under a computer controlled program to create a physical object. Now, let's take a look at the history of 3D printing. 3D printing began as an idea for accelerating industrial product development through faster prototyping. Even though there were a few patents beforehand, Chuck Hull is typically credited with the invention of a 3D printer via his stereolithography apparatus or SLA, patented in 1984. With this background in industrial manufacturing, most 3D printing technology was protected by patents held by companies in the industrial market. As patents expired, 3D printers geared for the consumer began to appear. Dr. Bryony Kaur, a technology analyst at ID TechX, explains 3D printing technologies have existed since before 1980s. However, it was not until the expiration of Stratasys patent in 2009 protecting their ownership of the fused deposition modeling (FDM) process that affordable consumer thermoplastic extrusion printers proliferated. The expiration of subsequent patents covering alternative additive manufacturing processes has further fueled this growth. Now let's go ahead and take a look at the 3D printing process. 3D printers build objects using a process known as additive manufacturing. Material is put down in layers, each layer adds to the previous layer and in turn becomes a base for the next layer. Most 3D printers in the consumer market use thermoplastic inks in the printing process. These polymers become soft and pliable within a temperature range and then resolidify when allowed to cool. The print bed is where the object is printed. It's usually covered with an adhesive material and with some inks. It also needs to be heated in order to minimize distortion in the printed object. The extruder temperature may be set manually depending on the model. The nozzle position is controlled by the microcontroller, which is directed by commands in the print file. Now that we know the process of 3D printing, let's go ahead and take a look at types of 3D printing. The first type is additive manufacturing. Additive manufacturing builds up 3D objects by depositing and fusing 2D layers of material. This method has almost no startup time or cost, making it ideal for prototyping. Parts can be made rapidly and discarded after use. Parts can also be produced in almost any geometry, which is one of the core strengths of 3D printing. Next up, we have subtractive manufacturing. Subtractive manufacturing, such as milling and turning, creates objects by removing material from a block of solid material that's also often referred to as blank. Almost any material can be machined in some way, making it a widely used technique. Because of the amount of control over every aspect of the process, this method is capable of producing incredibly accurate parts with high repeatability. Most designs require computer-aided manufacturing or CAM to plot customized tool paths for efficient material removal. which adds setup time and cost, but for the majority of designs, it's the most effective or cost effective method of production. The 3D printers can be categorized into one of the several types of processes. First one is wet polymerization, which is liquid photopolymer is cured by light. So the SLA, direct light processing, and continuous direct light processing are additive manufacturing processes that fall under the category of photopolymerization. After this, we have the material extrusion, in which the molten thermoplastic is deposited through a heated nozzle. So the material extrusion technology squeeze a material through a nozzle and onto a build plate, layer by layer. Fused deposition modeling or FDM falls under this category and is most widely used 3D printing technology. After this, we have the powder bed fusion. The powder bed fusion or PBF technologies use a heat source to induce fusion, also known as sintering or melting, between the particles of a plastic or metal powder, one layer at a time. Selective layer sintering or SLS, electron beam melting or EBM, and multi-jet fusion MJF all fall within this technology.
Just a quick info, guys. Intellipaat is providing hot training mentored by industry experts, the course link of which is given in the description below. Now, let's continue with the session.
All in all, powder particles are fused by a high energy source. After this, we have the material jetting. In this, droplets of liquid photosensitive fusing agent are deposited on a powder bed and cured by light. Material jetting technologies use EV light or heat to harden photopolymers, metals or wax, building parts one layer at a time. Nanoparticle jetting or NPJ and drop on demand DOD are two other types of material jetting. Then we have binder jetting. In this, droplets of liquid binding agent are deposited on a bed of granulated materials which are later sintered together. So the binder jetting uses an industrial print head to deposit a binding adhesive agent onto thin layers of powder material. Unlike the other 3D printing technologies, binder jetting does not require heat. Next up, we have direct energy deposition. In this, molten metal simultaneously deposited and fused. So direct energy deposition or DED creates 3D objects by melting powder material as it is deposited. It is mostly used with metal powders or wire and is often referred to as metal deposition. Laser engineered nest shape or lens and electron beam additive manufacture or EBAM also falls under this category. Last but not the least, we have sheet lamination. So in this, individual sheets of material are cut to shape and laminated together. This technology stacks and laminates thin sheets of material to make parts. There are a few different types of lamination to choose from, which can be bonding, ultrasonic welding, or brazing. And now that we are done with the different types of 3D printing, let's also talk about the 3D printing materials. The number of 3D printing materials grows rapidly every year as market demand for specific material and mechanical properties spurs advancements in material science. This makes it impossible to give a complete overview of all 3D printing materials, but each 3D printing process is only compatible with certain materials, so there are some easy generalizations to make. Thermoplastic and thermoset polymers are by far the most common 3D printing materials, but metals, composites, and ceramics can also be 3D printed. Another way of categorizing materials is by their properties, which is cheap, chemically resistant, dissolvable, flexible, durable, heat resistant, rigid, water resistant, UV resistant, etc. Many industrial applications require durable plastics such as nylon 12, and most hobbyist applications use either PLA or ABS, which are the most common materials used in FDM 3D printing. Now that we are done with the 3D printing materials, let's also take a look at the 3D printing design guidelines. The exact best practices and rules of thumb vary between the different 3D printing technologies, but there are certain features you always need to pay attention to. Some of these guidelines are supported wall thickness, unsupported wall thickness, and then we have supports and overhangs, embossed and engraved detail, then we have horizontal bridges, the holes, and then we have the connecting of moving parts, escape holes, minimum feature size, minimum pin diameter, and maximum tolerance. So these are the various design guidelines we have to follow for 3D printing. Now that we are done with this, let's also take a look at a few benefits of 3D printing. 3D printing is an exceptional tool for custom parts and rapid prototyping with a unique set of advantages, but also lags behind traditional manufacturing in some ways. The key benefits and limitations can be summarized as follows. So the very first benefit is the very low startup cost, very quick turnaround. Then we have the large range of available materials, And then we have the design freedom at no extra cost. And then each and every part can be easily customized as well. Although there are some limitations to 3D printing as well. So, first of all, it is less cost competitive at higher volumes, and then there is a limited accuracy and tolerances also. And then we have a lower strength and anisotropic material properties. Then again, it requires post processing and support removal. Now that we are done with the benefits of 3D printing, let's also take a look at a few applications of 3D printing. 3D printing is exceptionally useful for prototyping. Speed is everything in prototyping, and the ability to move from CAD to print with close to zero setup cost means 3D printers can produce parts fast and have great unit economics for single part and small runs. For printing production parts, speed and price are also very important, but the characteristics most commonly exploited are design freedom and ease of customization. In aerospace and automotive, topology optimized structures with a high strength to weight ratio are used for high performance parts, and components that previously required assembly can be consolidated into a single part. In healthcare, customization is critical. Most hearing aids manufactured in the US are made almost exclusively using 3D printing. In manufacturing, low run injection molds can be 3D printed from stiff, heat resistant plastics instead of machined from metal, making them much cheaper and faster to produce. So, coming back to applications of 3D printing, first of all, we have medical 3D printing. So, there are many applications of 3D printing in the medical industry. For each year, doctors and scientists come up with new and creative ways to use this fast growing technology. The speed and versatility of 3D printing makes it perfect for developing customized prosthetics and implants and patient specific replicas of bones, organs, and blood vessels. It is also used for 3D printing surgical tools, anatomical models, personalized medical equipment, and a range of other life saving innovations. Next up, we have automotive 3D printing. In the automotive industry, automakers use 3D printing to test form and fit, to experiment with aesthetic finishes, and make sure that all parts operate and interact as intended. It also provides a flexible solution for the quick turnaround of jigs, fixtures, and grips, creating bellows, engineering complex ducting, and rapidly manufacturing complex lightweight mounting brackets. Next up, we have the application of 3D printing jewelry. So, there are few reasons that so many designers use 3D printing to create jewelry. The technology allows jewelers to produce very complex, highly customizable designs, sidestepping some of the limitations of previously popular jewelry, making techniques such as CNC machining, handcrafting, and lost wax casting. Today, precious metals can be 3D printed in a variety of patterns and designs quickly and cost effectively. Now that we are done with these applications of 3D printing, let's also take a look at what do we have in the future for 3D printing. So where is 3D printing today? Is the hype over? Yes. And now the technology is reaching maturity. Hubs has been around since 2013, and they have been printing a 3D printing trend report every year since 2017. Over those years, we have watched the technology reach the height of the hype cycle, drop through the trough of disillusionment, and bounce back to where it is now, on the slope of enlightenment. The hype of the previous years was based on the idea of widespread consumer adoption. This was a misleading interpretation of where the technology could add value to the world. The most promising applications of 3D printing are in a very specific roles in the world of manufacturing. So in the future, we can expect 3D printing for scalability from rapid prototyping to production. Then we have making the supply chain more resilient through digitization. We can also have offering greater flexibility and more customized design in the future. The future of digital is all about materials, and we can create more sustainable future with 3D printing. And now that we have come to the end of the session, don't forget to subscribe to Intellipaat and press the bell icon to get the latest updates on Intellipaat. If you have any questions, mention them in the comment section below. We'll be happy to help you in your journey towards excellence. Thank you.
Just a quick info, guys. Intellipaat is providing hot training mentored by industry experts, the course link of which is given in the description below. Now, let's continue with the session.